Okay, so I'm going to show you a few different runs of the AISPACE applet, which you can find on AISPACE.org, but I am running it for you because there's some security concerns, so I figured I would just run it and do some demos myself. So the first demo I'm going to show you is depth first search, and it's depth first search with no pruning, no loop detection. All right. So what we're going to do, of course, our algorithm, we start with the only node on the frontier is the start node S. We're going to ignore the path cost for now. Just don't worry about that. Don't worry about how it gets values. We'll deal with that later. For depth first search, we don't really care about the path cost, so we're going to ignore that. And we're just trying to find a path. And right now, we don't have any paths from our start state to the goal, right? So what we're going to do is we start with the root of the graph on our frontier, and that's the only thing. I'm going to take a find step. We take the root off of the frontier, right, because it's the only thing on there. Another find step to find who are the neighbors of S. Well, the neighbors of S are N1 and N2. And so we're going to put back onto our frontier the path S goes to N1 and S goes to N2. All right. And like I said, just don't worry about that right now, right? So when you think about the frontier has the node N1 on it and the node N2, which represents the path S goes to N1 and S goes to N2, right? Now what we're going to do is we are going to take, we're going to look at our path, and whatever is the first one that we put on the frontier, we're going to take off. So that's this S goes to N1. So let's take a find step, and S goes to N1 is taken off the frontier. And now we say, who are its neighbors? Well, its neighbors are N3 and N4. And now we add those neighbors back onto the frontier at the bottom, right? So now we have S goes to N1, was our previous path. And now we have on the frontier, we have S goes to N1 goes to N3, right? S, N1, N3, S, N1, N4, right? And then at the very back of the path is S goes to N2 because we're implementing depth first search using a stack. So whenever we put anything onto the frontier, we always push it onto the stack. So it's first in, last out, right? Because it's a stack. So whatever we put in most recently is what's going to come out. So now we need to take another find step, right? And so we take the top thing on our stack, which is S goes to N1 goes to N3. So if I take a find step, we have S goes to N1 goes to N3 comes off. We look at the neighbors. There's only the neighbors of N3. There's only N7. So we take that path and we put it back on at the top of our stack, right? We push it on. So now I'm just going to run auto search and be kind of quiet and let you watch as things change. I've got it set, I believe, so that the speed is pretty slow so that you can watch this on the recording and pause the recording if you want to predict what's going to happen next. Okay? So maybe I'll stop the search for 1 second and let's see, where are we? So at this point, we have 3 either nodes or paths on our frontier, depending on how you want to think about it. So let's just look at it in terms of paths for a minute. We have the path S goes to N2, N5, N9, S goes to N2, N5, N10, and S goes to N2 and N6, right? And so we are going to pull the next path off of the top, right? Because we pushed this on the top of the stack. So we're going to take this guy off and find its neighbors. So let's take a find step. We pull that off, or pop it off, right? Pop it off the stack. Who are its neighbors? Those are its neighbors. And now we're going to push each of its neighbors back onto the stack, and we seem to do this in right to left order of neighbors so that we end up pulling the left neighbor off the stack next. So we look at it and the 13 is there before the 14, right? So now we have 1, 2, 3, 4 paths on the stack. Here's 1, Here's 2. Here's 3. And here's 4. And now I'm going to let it keep going. Now this is an interesting point to note. We've already found the goal in some sense, right? The goal is on our frontier. We picked a path that has the goal on the frontier, but we have not stopped because we only say that we are done if we have popped the goal off of the frontier. So right now, we've just taken this long path off of the frontier. We're going to see if we have any neighbors for N18. There's no neighbors, right? So we'll take another step. We didn't add any paths to the frontier, so now we're going to pop this off our stack, and we'll see the goal. So let's take a find step. Aha! Goal node reached. We popped this off. We see the goal. We are done.